Coming, right? So
Yes.
should I unshare it right now?
You can keep it like this. There's no issue.
Ma'am, it will be good to go to slideshow.
Yeah, I'm doing that.
Thank you, ma'am. Thank you.
Yeah.
Inventory details.
அவங்களுக்கு ஒரு காப்பி போயிடுச்சா இல்லை
நம்மளும் காப்பி கொடுத்துருக்கோம். எதுக்கு நீங்க போயிட்டு
சரி இப்போ யாருக்கு போடுறது பார்த்துட்டு அப்புறம் ஃபைல் பண்ண சொல்லுங்க
நம்மளோட இஆர்டி அந்த இது ஹாஃபேலி ரிப்போர்ட்டு கார்த்தி சார் காப்பி வருது காப்பி டிஎன்ஏயும் அந்த இதில் எக்கனாமிக் எஜுகேஷன் வேர்ல்ட் வைஸில் பப்ளிஷ் ஆகிருக்குங்க.
ஹர்ஷா இது
Dr. Latif, I think we shall proceed ahead now.
Yes, please, Dr. Shiraz.
Okay. A very good evening to all the participants, and I welcome you all in the day 3rd, session 4th and 5th, as today we are scheduled to have the 2 lectures. One from the Dr. V. Geeta Lakshmi, who is the Director, Crop Management, Tamil Nadu Agricultural University. She'll be deliberating upon the topic that's application of agromet advisory services to minimize the weather risks. And the second lecture that is scheduled at 6 p.m. today will be from Dr. Ramaraj AP, Estate Scientist, ICRISAT, Hyderabad, and he'll be presenting on the topic Climate Risk Management and Innovation System for Dairy and Agriculture. So we are pleased and honored to have with us Dr. V. Geeta Lakshmi, and I would request to Dr. Latif, Kuru's director, to formally invite and introduce our respected speaker to our participants. Dr. Latif.
Thank you, Dr. Shiraz. Good evening to all of you. So, ma'am is currently serving as Director for Crop Management in TNEU Coimbatore, and she is having a vast experience for the last 30 years. She is associated with climate change studies. Her field of specialization is actually agricultural meteorology, weather forecasting, agro-advisory services, climate change, and its impact assessment and developing adaptation options. Ma'am's scientific work has been recognized by CAGM, that is International Expert of CAGM, Commission for Agricultural Meteorology. It is a body of World Meteorological Organization in Geneva. She has also served as expert member in Science and Technology for Women from 2011 to 2013, that is DST, for climate change programs under the Ministry of Environment and Forest. Ma'am is also currently serving as core committee member in the expert committee for young scientists in the area of earth and atmospheric science in the Science and Engineering Research Board, that is SERB, Government of India. And she has been nominated as national level coordinator for NMSKCC, that is National Mission on Strategic Knowledge for Climate Change, and also serving as invited member of expert committee from 2016 to 2019. And she has also contributed for developing state action plan on climate change for Tamil Nadu for agriculture sector. She is also a co-chair of Science and Technology Innovation Policy 2020 Government of India for agriculture sector. She has obtained executive research projects from international and national organizations to the tune of around 30 crores, and has a collaboration with Australia, Norway, United Kingdom, Africa, United States of America, Japan, and many other countries. Madam has more than 100 research papers in a very high impact journals. She has guided 12 PhD scholars and about 25 MSc scholars. So she is I think, mother of agrometeorology in India. So I welcome him on behalf of participants, on behalf of organizing committee. Ma'am, please.
Before our respected speaker will start, let me inform all the participants that live streaming of the session is on YouTube channel and the Facebook channel, which has been already uploaded on our two participant WhatsApp groups. I may request all the participants to share the same links with your friends, those who could not register on time for this training program, so that they can watch the live session of the important lecture of our respected speaker. Madam, please proceed. Thank you.
Thank you very much, and it's indeed a great pleasure for me to be part of this initiative. And I take this opportunity to thank the organizers for inviting me to give this lecture. And always it is a pleasure to engage, and it's introduced to me in a very nice manner. Thanks for that again. So now I'm trying to share the screen.
Ma'am,
All pleasure ours, ma'am. All pleasure ours.
ma'am, please. No.
Okay.
Yes, ma'am. We are now good to go.
Yes. Can I go ahead?
Yes, ma'am.
Yes.
Please.
Yeah.
Please.
Okay. Thank you so much. The topic of today's discussion is approaches and applications of agromet advisory services to minimize weather risk in agriculture. So that is the topic. You know, India is its economy itself is depending on agriculture, and up to 70% depends on agriculture. So, but the one important thing is most of our farmers are small and marginal, who are facing lot of weather vagaries, and they are put into struggle, and they are highly vulnerable for the changing climatic condition as well as all weather vagaries itself. So if we just see, I'm not able to move my slide forward. Okay, good. We know that the population is increasing to the tune of 1.13 per annum. So if the population increase is going to happen like this, we will definitely reach doubling of the population around the 2060s or 2070s. Already India is pressurized with population, and we will surpass China. Maybe the people are predicting that even in 2022, there is a possibility of Indian population increasing China population. So that's what is the predictions are saying. So if that be the case, we have to become much more cautious, and we have to definitely feed our people. We cannot anymore go as a begging bubble. So we have to become self-sufficient. So for that, we have to increase our production to around 60% more. So 60% more production with the dwindling resources. Especially our land area is getting down because of non-agricultural uses. If you just see, every year lot of productive agricultural land is going into other non-agricultural uses. People are just putting it all the land area which is along the road, they are just converting it as a housing plots, and they are selling it for a very high rate, and that interest fetches higher income than agriculture income. So people are really using the land for non-agricultural use. That is the biggest problem we are having. The second biggest issue is the change in climatic condition, which actually leads to lot of variation in the monsoon rainfall. So monsoon rainfall is the real finance minister for India. When the monsoon rainfall is very good, our production levels will be very good, and then we will be very happy. Whereas if the monsoon rainfall is not good, naturally all our economy will go down. I'll be just giving some of the examples in my subsequent slides. Then the second important thing is urbanization, growing urbanization. Now nobody wants to go and sit in the hot sun and work in the field. Everybody wants a white collar job, and most of the people who are aged only are taking a farming, and all the youngsters, the daughters and sons of farmer, they are trying to move to the urban cities to take up some job of either in the software side or in so many other sectors. They are taking the jobs, and only very few percentage of the people are sticking on to agriculture side. So the urbanization is again very important issue that is threatening to the food security. Then, as I already discussed, the decreasing cropland, that is the biggest issue which we are facing right now. Continuing crop loss. Every year, one or the other, the year is becoming an extreme year for the agriculture, especially for the agriculture. One good example is maybe the same agriculture season, one part of the country is facing very good rainfall, flooding, that affects the crop production. For example, very recently, we received a heavy rainfall in Karnataka, and also in Tamil Nadu, where we lost almost the crop ready for harvest was lost. Exactly, if you just see in Tamil Nadu alone, around 2.5 lakh hectares of area, the producers are actually, it's not going to come as a very good produce because it got caught in the rainfall, and it is in the fag end of the harvesting stage. So this is one thing which is happening in one part. In the other part of the state or even the country, the drought is becoming a major problem which limits the crop production. So either it is because of the drought, or it is because of the flood, or because of some other extreme event like cyclonic storms and so on, where the wind speed is so high, which results in crop losses. Then declining crop production. Like now there is a plateau that has come, whatever the input you are putting, but still that is not turning out as an yield. So there is a declining crop production. So now the specific research is happening that to break the yield plateau, that is what is happening around the scientific community. So how much ever fertilizer you dump, but it is not yielding into yield increase. So breaking the yield barrier is one of the important research that is going on. Then declining biodiversity. Previously when we just if you just if you just scoop the soil out, you will find at least 2 or 3 earthworms and whole lot of microorganisms. Now if you just see your soil, because of the overuse of chemicals and fertilizers, your soil has become sterile. There is no life or activity in the soil. So the soil is becoming very poor. That leads to a declining in biodiversity. So these are all some of the factors which are influencing food security in the very negative way. Okay, weather and agriculture. Weather and climate, they are the biggest production risk. Now, weather actually, it is a short-term impact. It creates a short-term impact. Whereas climate, it creates long-term impact. So what we should do for the short-term impact, we have to do some management aspects. Whereas for the climate, which poses the long-term impact, we have long-term policy adjustment and required. Mainly, strong living all environmental risk factor. Okay, there is a small statistics. National Commission on Agriculture in the yield is mainly because of the rainfall induced factors. Mainly, if you just see out of that, if you take that 40 to 55% as 100%, out of that, the drought and low rainfall causes the major impact. So the production loss is 70%, which is accounted from the drought and low rainfall. Whereas the flood and excess rainfall, that cause 20% of the loss, but others like storms, earthquakes, diseases, pests, and all negligence, etc., which causes only 10%. So the rainfall related losses are much more higher compared to other weather events. Okay, so the most important thing is the weather vagaries has a cascading impact. If you I just have given one simple example. For example, if we have below normal monsoon, okay, this will result in crop failure, and because of the drought, the crop failure might occur. So in this below normal situation, definitely it will lead to agricultural production, lowering of agricultural production. So the agriculture production goes down very sharply. That will again have a cascading impact on the rural consumption, and the demand is becoming weak. Okay, so when there is less production, naturally the purchasing power of the people will go down. Automatically the rural consumption will also go down. So that will again have a cascading impact on weak rural demand that affects urban demand as well. So not only the rural, but also the urban demand is affected. The industrial production and gross capital formation, that also will go down. Finally, the entire economy slows down sharply. So it is not only that one particular sector gets impacted, but cascading impact, as a cascading impact, it affects all the other sectors. Coming to the phase-wise impact of weather risk. Okay, we are growing a crop, we are sowing and we are harvesting. In between, the crop has so many stages. Which stage of the crop is much sensitive for the weather vagaries? So there are a lot of studies, and it was reported that from the peak vegetative stage until the grain formation stage, it is the most important critical stage for the weather events. So if the crop escapes this particular stage from the weather vagaries, then we can have very good harvest. That is what is the indication. Okay, let's see what is happening to our inter-annual variation anomaly in the Indian summer monsoon. You know, this is a very famous slide everyone shows. So this actually gives more than 100 years of data. It starts from 1970s onwards, and then it goes to current time scale. So all the green ones are very good excess rainfall years. All the red ones are drought years, and the black ones are normal years. If you just see, there is no trend as far as Indian monsoon is concerned. Like it is not neither increasing nor decreasing. But one thing is, if you just see in the recent year, the red lines are much prominent rather than the green lines. And not only that, the red lines, consecutive red lines, are really worrying us. because no, our farmers are small farmers and marginal farmers. So 1 year drought they can manage. For example, they can sell their animals, or they can just manage by getting some debts and so on. Second year, they can just again sell their animal and then they can manage. But third year, if it becomes a dry year, then naturally most of the people, the farmers, will become the agricultural laborers, or they might even change to other sectors. Maybe they will just go for some other employment activity, and they will just go as a construction labor, or they might go as workers in the spinning mills and so on. Even some of the people are going for brick making and so on. So this kind of consecutive droughts are becoming much more higher, and in the event of changing climatic condition, this kind of situation is expected to become more intense and more frequent. That is what is really worrying all of us. So this slide explains trends in agricultural rainfall and agricultural growth. So this is something a recent year, last decade and two decades it has been depicted. So the bars, the gray bars are showing the rainfall quantum. The blue line is actually showing the agricultural growth. If you just see, whenever there is low rainfall, naturally there is a dip in agricultural production. So it is almost like 1-to-1 correlation. To better depict it, the impact of drought on food grain production, if you just see the percentage deviation in Indian summer monsoon is given in the x-axis, whereas the impact on food grain production is given on the y-axis. So whenever there is a low rainfall, all the red dots indicates low rainfall. Whenever there is low rainfall, naturally there is a negative deviation. There is a negative deviation in the food grain production as well. See, this is the negative deviation in the food grain production, and this side it is negative deviation in the rainfall. So whenever there is a low rainfall, we get only lesser food grain production. At the same time, whenever there is increase in rainfall, the food grain production also increases. There are also some outliers, which means even high rainfall, if it is not falling at the time when it's required, then it results in lower food grain production. But by and large, the trend is whenever there is a good monsoon, we get good production, and we get sufficient food grain in safe. So this is what the indication. Okay, so variability in weather and climate, components of variability in weather and climate in India. More variable rainfall. The rainfall is highly variable. So just in 2 kilometers distance, aerial distance, you will find lot of variability as far as rainfall is concerned. Second thing is increased extreme weather events. I've got few slides to showcase you how the increased extreme weather events are happening. Then erratic onset, advance and retrieval of monsoon. I can quote one example. I was actually working with some of the watershed development programs which are funded by NABARD. So I was working in one of the, just around 50 kilometers away from Coimbatore. There are two watersheds which was funded by NABARD. So there what happened, you know, I was closely associating with them. The southwest monsoon, normally it starts from June and ends in September, right? So that particular year, it's just 3 years before, what happened was there was not even a single drop of rainfall starting from the January month, 1 that year until 28th of August. There was not even a single drop of rain that fall on the land. So it was so dry, the land actually got hardened, and on 28th, 29th and 30th of August, almost whatever the rain that has to come during the entire southwest monsoon period, the entire rainfall that was received in the 3 rainy days. So really speaking, when we just take the statistics out of it, that year is a normal rainfall year. But when we just see the distribution, then it is definitely not a normal rainfall year, because whatever the rainfall that was received on the land, that could not be captured because the soil has become so hard because of the continuous dry time, and then all the rains that were falling on the ground, that actually it went as a runoff. Okay, so that is how. So erratic onset, advancement as well as retrieval of monsoon, that is important. That is one of the important issue as far as our country is concerned. then shift in active and break cycles. And this is a very common phenomena. Like the monsoon will occur on right time, but there will be lot of active break spells will be there, active as well as break spells will be there. If the break spell comes in the critical period, like in the flowering stage or grain filling stage, gone. That year we will not get, at least 80% of the production is also not possible. So this is one of the issue. Intensity and frequency of monsoon system. And another important thing, especially central India and above that area, heat and cold wave. These are the two important things. Last few years, I just could get the data from 2000 to 2014. What happened to all India summer monsoon rainfall departure, and what are the things that happened over years I've given. But if you just see 2001, 2002, 3, 4, all these years, if you just say 2003 was an exemption, but all the 3 years we had negative deviation in rainfall. Again, if you just come to 2009, this is one of the greatest year where minus 23% is the departure of all India summer monsoon. And all India, whole of the India had severe drought. Okay, and most of the years, even in 2003, if you see, the rainfall was a little positive, plus 2% of the deviation, but 20 days heat wave during May 2003 in AP. So all those things are listed over here. Each and every year is becoming important weather-wise. So that is how the Indian summer monsoon as well as Indian weather is playing a very crucial role in deciding agriculture productivity. So this is one of the extreme weather event damages to the crop. I just picked a few case studies, especially which happened in my part of the state. This is Thane cyclone. Thane cyclone, it happened on December 2011. So this is one of the very famous cyclone which happened, and it devastated so much of area. It devastated almost 80,000 hectares of agriculture area and 28,000 hectares of horticulture area. So more than 110,000 hectares of land area, agriculturally important land area, was highly devastated because of this particular cyclone. Like a heavy rainfall, and also it uprooted the entire banana. So this was taken at that particular point of time. You can just see here. And very recently, for example, 2018 November, we had a cyclone. This was a very severe cyclonic storm. What happened? One day, the storm occurred like this. The total one day total wind speed was 230 kilometers in 24 hours. But the pattern it happened was, the heavy wind started at around 11 o'clock in the night, and then it peaked up, and at one particular point of time, the wind speed was around 130 to 150 kilometers per hour, and then it slowed down. So it entirely devastated the coconut gardens. Like entire coconut, you can just see over here, all those trees are as if it was uprooted and thrown outside. It was completely damaged. It got completely damaged. More than something like lakhs and lakhs of trees have gone. So if I'm very right, I think it is something around 40-50 lakh trees, coconut trees have gone, especially in Tanjore, Pattukotte, that area. So that was the impact it had. Again, in May 2020, Amphan cyclone, 500 acres of banana uprooted. So like this, there are a lot of examples are happening. Just in 2018 alone, 4 cyclones. These are the 4 cyclones in India which hit India, different parts of India. So this Day cyclone, it hit Odisha, and this particular cyclone on October 11th, it hit Andhra Pradesh, Odisha, West Bengal and Bangladesh. And then Gaja cyclone, which I just now described, Tamil Nadu, and then this cyclone in Andhra Pradesh. So if you just see every cyclone, it devastated most of the agriculture area, and also it killed people. And this is the major impact. Within 1 year, all the 4 severe cyclones happened like this. Again, in 2019, we had another 4 cyclones. So that was also, it's very severe. And one of the cyclone was even the super cyclonic storm with 240 kilometers per hour. And another cyclone which hit Gujarat, that was again 185 kilometers per hour. So it was the kind of the cyclonic storms and other things are also it's hitting the agriculturally productive area. So coming to this year, just very recently, just 1 week before, AP and Telangana, every one of you must have heard through the televisions and then the newspapers, completely because of the high intense rainfall, complete Telangana and Hyderabad, everywhere it was flooding, 11 to 24 centimeters of rainfall in 100 locations in Andhra Pradesh. So this was the kind of spread of rainfall. It's a widespread heavy rainfall event which flooded, and 35 people reported to lost their lives. So this was the one which happened very recently in 2020. So what are the climatic trends in India? When we just look at the climatic trends in India, the trend is like there are few places where in southern India as well as in northwestern part of India, the trend of rainfall, it is just saying that it is positive. Whereas in the central India, in eastern India, the trend is a little negative. So if we just look at the temperatures, the temperature is increasing. The temperature is definitely increasing. But the last few years, the magnitude with which the temperature is increasing is becoming very, very high. So this is really, it is a worrying factor. The temperatures are increasing, the rainfall is having a erratic behavior. So that is where the changing climatic conditions are really impacting us. Okay, now why I was saying all this thing is, if we could forecast the weather in advance, then definitely, though not we can save our crops 100%, but we can take some precautions. One example I'm just quoting here. So I was just telling the Gaja cyclone which uprooted the entire coconut garden. You know, one farmer, entire coconut garden, it fell down. Farmer could save his coconut palms. You know, like he came to know that there is going to be severe storm in that particular day. Immediately what he did was, he just pruned his coconut fronds. He just cut down most of the coconut fronds, left only 4 or 5 fronds. You know, people surrounding him, they were actually laughing at him. Why are you doing this? You are losing the potentially productive leaves. What are you doing like this? They were just seeing him. But the following night, the severe storm occurred. All the other people lost the entire coconut. But this one farmer's coconut plantation could be saved. This became a history, and you know, it became a case study for all of us to learn. If you could act depending upon the forecast, if you could take decisions and act accordingly, you can save your crop. Now that farmer is so happy that he could crop, at least this year he will lose his production, but from next year onwards he will definitely get the original production. Whereas all the other farmers, it took at least 4 to 5 months to remove the debris from their field, and then they had to replant it with the support of government, and they have to wait at least 4 to 5 years for their palms to initiate fruiting. So this is the condition which was happening. So weather forecasting is becoming very, very important. And Indian weather is such a dynamic weather. You know, like people used to say, weather forecasters used to say, Indian weather is behaving like a millionaire, whereas Europe weather is behaving like a poor man. For example, Europe weather, it is like, if they predict that this is going to happen, rainfall is going to happen at 10 p.m. in the night, it will exactly happen. Okay. Whereas the Indian weather, if we forecast 10 o'clock, say 10 o'clock, you are going to get some 20 millimeters of rainfall. Maybe it may occur or it may not occur. And if you forecast in one place, it will go and occur in another place, because our atmosphere is highly dynamic. This is mainly because of location. we are sitting, our India is starting just 8°4' above the equatorial line. So our atmosphere is highly dynamic because of the high solar activity. Whereas Europe weather, it is very static because it is in the higher latitude side. So it is very static. The air mass doesn't very dynamically change from one pattern to the other pattern. So even the forecasters in the Western countries, they agree that if Indian weather could be forecasted at 60 to 70% accuracy, that is equivalent to 100% accurate weather forecasting in the European condition. So they themselves have agreed, and lot of research is going on from the US as well as Europe on Indian weather prediction. So that is what is happening right now. Okay, so the data is very, very important. As far as forecasting is concerned, data is very, very important. So we have to strengthen automatic weather stations, or at least the rain gauge stations and the temperature stations, so that we get the wealth of information. So in Tamil Nadu, what we have done is, we have got automatic weather station at block level. Each block is having one automatic weather station which record 10 weather parameters. So we get the continuous update of every hour what is happening in our state. So that actually helps us in looking at the past weather as
Wes,
Yes, sir. Some network issues.
has she lost connection or what? I think
Yeah,
she has lost the
ma'am has
connection.
lost connection.
This is from our side, or she is having a weak connection there?
No,
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 I
sir.
think
From ma'am side.
poor
But
connection from her.
Okay. So she may join again. Huh?
Mm-hmm.
she has to join again, sir.
She has lost the connection actually. Dear participants, we regret the inconvenience caused because of the poor connectivity from our respected speaker's side. So she'll be with us shortly. Kindly have a patience for 1 or 2 minutes till she will join again.
Ma'am is unable to join again, sir.
वो actually
Ma'am has joined again, sir.
आपके द्वारा डायल की
Sorry that I got disconnected because of the
Yeah,
internet
No
connectivity. Yeah,
issues, ma'am. No issues. Please you
no
continue.
issue.
No issues.
I'm
Ma'am, you
just
have to share the screen again.
I'm just doing that.
Yeah.
Okay.
Slide
So
show.
this is the problem with the high tech.
Yeah.
Okay.
Okay, so I was just saying that we are recording 10 different weather parameters for different purposes. And one advancement we made is the automated agro advisory services. So this I will explain little bit later when I'm coming for the forecast information. So we use this automated weather station information that goes into the data logger, that goes into the modem, gets in the server, and then it gets into the net. After processing the data, it just gets into the net, and then we are able to give the real-time weather information to the general public as well as to the farming community. So that's what is happening here. So this is link for that we are giving. This is a Tamil Nadu Agri Weather Network. So we have kept it as town.tnau.ac.in. Here we are actually, if we just click on that, then we will go to the weather page, and then we used to get all the weather related information. So this is a sample capture. I've done it. So how do we give the weather information? So this is the one, the date and time. So if you just see every 1 hour, one line is added giving the real-time weather information every day. So this is the air temperature, relative humidity, wind speed, wind direction, soil moisture, soil temperature, rainfall, solar radiation, atmospheric pressure, and leaf wetness. These are the parameters that is getting depicted every hour. And then you can get the last yesterday's information. You can get last 7 days information. Up to 1 month the information is kept alive on the web, so that people can definitely really use it. Otherwise, no, we get lot of information we collect, but we never use it. So we just wanted people to use it, so we are keeping it on the public domain. So this is the forecasting page, where we just give for the next day, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. So for next 7 days, we just give the forecast information. So this is what is expected. So like that, we get the forecast information. So we keep the real information, we give the forecast information, and then we also give agro to the farming community. Okay, now I'm just going to go on to my exact topic of weather forecasting. So we have got different ranges of weather forecasting, starting from nowcasting, short range forecast, medium range forecast, and long range forecast. So within medium and long range forecast, now we have got extended range forecast. In the long range forecast, we have got seasonal climate forecast, and these are otherwise extended range weather forecast is also available. So these are all the forecast information. Seamless forecast information is available for the farming community to take weather-based farming decision. They can very well do response farming. So seamless weather forecast information means they can use the seasonal rainfall forecast for deciding some of the important strategic decision, whereas the in-between forecast, they can use it for tactical decisions. So how this information is used by many people? For example, this nowcasting, this has a very limited usage in the case of agriculture. Maybe nowcasting is just within 12 to 24 hours what is going to happen. Even if you give the forecast information, farmers will not have much time to act on this particular forecast information. So mainly, maybe if they have dried the produces somewhere outside, they can just take it and store it, and that is what they could do it. So this has a limited scope for agriculture, but for aviation purpose, this has a very great scope. So this is how nowcasting is useful. Coming to the short range forecast, this short range forecast again has a limited scope, almost 1 day plus 1 day out of 2 days. It has a 2 to 3 days maximum short range forecast is there. But has limited use in agriculture. Whereas medium range weather forecast, it is very much useful, and almost all the state agriculture universities are now collaborating with India Meteorological Department, and we get the weather forecast information and then we use it for preparing the agro advisory services. So this is one of the thing which is very much useful for us. This extended range forecast is highly useful because it is almost for a month. Medium range to long range, in between this extended range forecast is there. This is very useful, especially for the input managers, agricultural traders, and all the other people. They can source the input for the use of the farming community at the later stage. So for that, this extended range forecast is highly useful. Long range forecast is really useful for taking strategic decisions. Let us see some of the examples how we are doing it. Strategic decisions means it is a one-time decision. So the farmer cannot make any alteration crop, whether to grow it on a flat bed or to take it on a raised bed. That is what is the strategic decision. Cultivar selection. Once he chooses the cultivar, then after that he cannot change it, because now if you dibble it, if you sow it, then you cannot change it. That is what is the strategic decision. It is called one-time decision. Planting density, row spacing, all those things are one-time decision. Whereas tactical decision is from time to time you can change it. Whether you need irrigation depending upon the weather condition, or you need to apply fertilizer, weeding, pesticide application, harvesting, everything are tactical decisions. So these are some of the agricultural decisions depending upon the weather. So one example, like what is the strategic decision they can do? The farmer can decide whether to go for planting cotton or to go for sorghum. If the forecast information, seasonal forecast information is lesser than average rainfall, then the farmer has to decide if he has 10 acres of land area, how much to go with high water requiring crop and how much to go with low water requiring crop. So how much risk he can take it. That's what is done with this particular kind of decision. So whether to plant cotton or sorghum, how many acres of cotton, how many acres of sorghum, whether to go for flatbed or to go for a ridges and furrow, land configuration decision, what variety to choose, either to go with a drought hardy variety or to go with a variety which is high yielding. So this decision also he has to take. What planting density to adapt, all those things he can do it. So we had a lot of case studies, like using this particular seasonal rainfall prediction, what type of decisions they can take it and how it will be helpful for the farming community. We've got a lot of case studies of farmers. Okay, how the seasonal prediction is done. As of now, India Meteorological Department is giving seasonal prediction for the whole of the state, and they give it for southern peninsular India, eastern India, western India, central India, and northern India. But this particular spatial scale is not very much useful for the farmers to take decisions. You know, southern India, we have 5 states. So starting Kerala, Tamil Nadu, Karnataka, Andhra Pradesh, and Telangana, one forecast above average rainfall or something like that is going to help us, because whenever there is high rainfall in Karnataka may be there, but Tamil Nadu will never get any rainfall. So this sort of problems we always face. So what we do is we develop our own forecast depending upon many predictors. So we have seasonal climate forecast of Tamil Nadu, and then we use sea surface temperature, Indian Ocean and Pacific Ocean. We use also El Nino, La Nina conditions. We have analyzed and established a very good relationship with the ENSO conditions and our location rainfall. And for that, as a proxy, we use Southern Oscillation Index values, and we use Australian Rainman software for predicting the seasonal rainfall prediction. You know, like this ENSO based forecast is really important because now we have already established. So El Nino means it is a warm La Nina means it is a cool condition. I think this everybody knows. I don't have to explain this slide too much, but whenever there is an El Nino, the entire India, except Tamil Nadu and little bit of Karnataka, entire India will have a negative deviation in the southwest monsoon most of the time. It is not one-to-one relationship, but most of the time. Whereas in other countries, I worked with Australian scientists in this particular project. I got trained in Melbourne, Bureau of Meteorology in Melbourne in Australia for developing this kind of a forecast. So there, like this ENSO monsoon relationship for Australia is almost one-to-one. Whenever there is an El Nino, they are going to get definitely dry period. So the forecast is given much ahead of the rainy season, start of the rainy season. So what the farmers used to, in Australian condition, it is all range land, right? Most of the places are range land. They used to have some 300, 400 acres of range land. Each farmer, even the small farmer will have 300 to 400 acres of land. Big farmer will have more than 3,000 acres of land. So there, what they used to do is they will put an enclosure, kind of for every 10 acres, they will put an enclosure. And for 1 acre, if the grass growth is 10 animals, that is called the carrying capacity. So depending upon the carrying capacity, they will let the number of animals inside, and the animals will grow, and whatever the grass that is grown over there, the animals will feed, and then there will be here and there will be water tanks that will go and drink, and that's how the system works. Whenever they expect El Nino, naturally there is going to be less rainfall. If there is less rainfall, there is going to be less grass growth. So immediately the farmers get sensitized, and they will reduce the number of animals in their area. So once before the drought sets in, if they sell the animals, the animal will fetch higher price. Whereas once the drought sets in, the purchasing power of the people will go down. So definitely the animals will not be sold for a higher prices. So wisely they manage the herd size so that they get better prices. At the same time, if there is La Nina, immediately they will buy animals, they will increase the herd size. That's how they just behave it. So similarly, we try to establish some of the relationship, and accordingly, what we have done is we are forecasting our southwest monsoon at a district scale. Right now, we are forecasting. So this is the forecast which we have developed for southwest monsoon and the coming northeast monsoon, the ongoing northeast monsoon. So our southwest monsoon forecast, what we have given is, these are the areas, these are the districts where lesser than average rainfall is expected, whereas these are the areas where normal rainfall is expected. This became almost 80% true. And this one, the right hand panel, this is the forecast which we developed based on the seasonal rainfall forecast, based on the ENSO anomaly as well as Indian Ocean dipole. So we use both El Nino condition as well as Indian Ocean dipole values for projecting our location specific rainfall, for which we use Australian Rainman product. So with that, we have developed this forecast. So we give kind of a granular level forecast, micro level at the district scale forecast. This forecast, as soon as we develop, we just give it to the authorities, district authorities, district collector, then joint director of agriculture, and also extension officials, so that this forecast, and also we release it in the press and the mass media. So this goes to farming community. Based on that, the farmers are tuned to take decisions now. So this is one of the important things which we do it as far as seasonal climate predictions are done. Coming to the medium range weather forecast, there are a lot of global models, regional models, and mesoscale models are used. So India Meteorological giving the forecast to us. In addition to that, in Tamil Nadu Agriculture University, we are running the WRF model, Weather Resource Forecast Model, and we try to generate next 7 days weather forecast information. We put it on our website, and it is a dynamical one. Every day it changes. So today it will have for the next 7 days. Tomorrow it will have for tomorrow, from tomorrow to next 7 days. So like that, we run the model, and then we give the weather forecast information for the benefit of the farming community. And we also run the crop simulation models to develop agro advisories and give them precise advisories to the farming community. coming to for developing the advisories, we need to establish some of the relationship between the weather and crop. That studies are also going on. I'm just giving one or two examples. For example, at a particular stage, if the temperature increases by 2 degrees Celsius, the rice yield will decrease by 0.75 tons per hectare. So this is what we could see. Like that, we have developed so much of weather crop weather relationship, and that we are using it for developing automated agro advisory services. So Tamil Nadu Agriculture University is pioneering in automated agro advisory services preparation. In that, what we have done is we have created weather scenarios. So we have created almost 154 weather scenarios, and we have taken 108 per state for each of the weather scenario. Weather scenario means it is combination of weather, taking into consideration of past weather as well as future forecasted weather. If the past 4 days weather, there was no rainfall, then it is a dry weather, and we also take into consideration of temperature, and we also look at the future weather because we ourselves are generating the weather forecast. So both the things we just look at, and we create a weather scenario. For example, if the weather scenario is you are going to get rainfall for the next 3 days, and your temperature is going to be -2 degree from the normal, lesser than normal, 2 degree lesser than normal. If that is the forecast, immediately, depending upon the stage of the crop, we have got advisories developed and put it in a bin. So we have got a program, and through artificial neural network and artificial intelligence, it will pick the right advisory and it will send to the farming community. As far as the farmers are concerned, what we have done is each farmer can register with us with his mobile number. So we have developed an app for that. So with that app, with his mobile number, he can register for his own crop, and only to the farmer who grows paddy, the advisory related to paddy only will go to him. And the farmer who grows mango, the advisory related to mango only will go to him. So like that services we have started in our state, and it is growing very successfully. It is going, and this is pest and disease forecasting. So that also it forms a part of the advisory network now. So these are all some of the advisories. For example, so as a result of that, the weather consciousness among the farming community improved, and attitude towards taking decision depending upon the anticipated weather conditions are also improved, and input use efficiency is improved a lot. I've got a slide to show you for that. Reduction in cost of cultivation, the risk coverage is there. We are also working with the insurance companies to fix up the weather perils so that they give better services to the farming community. Reduction in yield loss, making headway towards more sustainable agriculture, and widening farmers network. These are all some of the things. I think this is well aware of it. So we used to calculate the economic benefit because of the medium range weather forecast. So we give some advice. What is the additional cost to take care of that advice, and what is the additional return? So this is how we calculate it for different crops. These are some examples for tomato, maize, banana, and turmeric, and so on. So each and every crop, we could see that weather-based farming definitely results in increasing the yield, at the same time reducing the cost of cultivation. And for the communication, as I said, like we have got all modes of communication. So we have got radio communication, television, postal, SMS, all those things. But now the most preferred one is SMS, because every farmer is having smartphone, and it goes as a SMS and voice message. So he can repeatedly hear the advisories, and it is done right now twice a week. And now we are trying to make it as a dynamical. So it will be also whenever he wants, he can get the messages as well. So we are doing that advancement as well. We are also, as I said, we are also doing for the policy support, crop insurance against weather vagaries. So that also we are just doing it. Especially, we are working very closely with the Department of Agriculture, State Department of Agriculture, so that we can give policy support based on our forecast information. So that's what is happening right now. So this is one of the impact of weather forecast on farm production. So we just wanted to see like what is the impact of our weather forecast information. There was increase in area under cultivation because of the seasonal climate forecast. There was reduction in seed rate. There was reduction in fertilizer application. Plant protection chemicals was saved. Change was also there. Increase in. To conclude, real-time weather forecast information is very much important for becoming to get preparedness as well as to manage the weather risk. Better forecast, better preparedness. So we have to be very cautious in giving the forecast to the farming community. Once you develop the confidence